Free audio post-production by alphonic.com.
Big deal is for everybody who has concern about space weather, but especially all the technology that we rely on so much. It's probably out as we go through this. There is catastrophic space weather that could happen. It could disrupt so many of our societies when in life. And that's what we don't care about today. So with that said, we'll move on. So let's talk about a few historical examples. I'm learning even more about the storm of 1921. One of the professors that used to work here at CU, actually, Gloria Smith, she's been doing a little bit more research about these events in one of my 1970. But this could have been one of the historic level events. We just didn't have a massive interconnected power grid yet. It was in the making of an early stage. There was electric power. But there was a storm that happened, and I won't get into the types of storm. We'll talk about it as we go along and get into more detail. But this storm provided a wide range of impact the electric code. Fires started and transformer damage that existed at the time, particularly one of because of damage sustained from a storm called the geomagnetic storm, which we'll learn about more as we go. Talking about something happening on the sun. You can see some of the headlines at the time, pretty dramatic things going on. People still didn't understand space weather, so they think the aurora is causing these things. No, that's not the case. The aurora is an effect from space weather storms. A very beautiful and pretty one. And the aurora alone does cause some impacts, but nothing to this scale. It's really about the underlying cause that creates the aurora. As I said, this storm could have been a benchmark storm. We're worrying more and more about it. If this storm hit us today, I'm not sure where we'd be at, but we are very prepared today that we go through learn more about what we're doing at the Space Weather Prediction Center. And by the way, Space Weather Prediction Center, SWPC for short. From here on out, I'm just going to say SWPC at Space Weather Prediction Center. Another storm in 1967 could have caused World War III because space weather impacts not only the things that we know about, but Department of War, Department of Defense type issues over the last many years. And as severe Cold War going on, as we all know, I was part of that in my tour in West Berlin when it was still West Berlin, 1986 to 1990. I'm pleased you said, are they all coming down? They came down in the last month that I was there. But in 1967, a threat happened from something on the sun that made it look like radar signals were being jammed. It made it look like communications were getting disrupted intentionally from an adversary. Something to say. This is very fascinating YouTube video from a talk that Dr. Doris gave on this exact topic. I recommend checking it out because she's a very good speaker and it's a very fascinating talk. But essentially what happened was we had space weather was kind of being watched by, I think what was the Space Environment Center at the time, but really by my Air Force profession. It was an Air Force officer who realized that there was a space weather event that was probably the cause of this, and they were able to get that word out quickly so that things didn't escalate. Now, you may wonder about information sharing. Well, here's a good example of why we want the enemy or our adversaries to know what's going on in space. Because if we have a concern, they may have the opposite concern. They may think we're trying to attack them. You don't want that. So everything we provide, for the most part, is available on our public webpage, and anybody around the world can look at it. And that's a good thing for us. 1972, once again, this is another storm that's being looked at for maybe not a benchmark level event, but much more stronger than perhaps we even realized that it was at the time. This storm also was a geomagnetic storm. This one was so fierce and strong that it actually set off mines in the ocean near Vietnam. Magnetic triggered mines for ships started blowing up because of a geomagnetic storm that was happening, actually disrupted those upgrades. So that's a pretty significant impact. Telecommunications were disrupted. AT&T was having trouble with the transoceanic cables at the time. Now we're going into different ways of communicating, but some of those still exist today. So, important one here. The bottom of, because we're bound in space. We just did Artemis 2, astronauts going back around the moon for the first time since the Apollo era. We're going to land back in the moon with Artemis 4 if they stay on track. This was right in between the final two Apollo missions. The same story had all sorts of different things associated with it. One was a solar radiation storm. That storm as things went on, they thought that maybe that would could have been impactful to the astronauts to the point of potentially even lethal. The experts don't think that it will today. They think it could have caused pretty notable radiation sickness, but they don't think it would have been deadly. But we still have concerns about this. We didn't know this kind of thing was going on at the time, and we were blindly sending astronauts into space, hoping for success, right? So right in between those two missions, 3 months after Apollo 16 and 3 months before Apollo 17, this storm happened. What would happen today if that happened during Artemis 2 or potentially during Artemis 4 when we land back in the moon? Well, we've gotten a lot better in how we design spacecraft, as spacesuits, planning these events, and the support we provide. So we're pretty certain this probably would not stop the mission, but it certainly would cause the astronauts to take some protective actions if they, you don't want to hear about it, right? You're all told to duck and cover when you're outside, hiding out there, the lightning storm happens, right? You're not supposed to get under a tree, despite the fact it's probably raining and hailing on you. You're supposed to duck and cover so you don't get killed by lightning. For the astronauts at Artemis 2, as they were planning this, I'm kind of getting ahead of myself here, but originally the plan was that this kind of radiation storm kicked into gear while they were up there. They were going to have to pull floor tiles in the Orion capsule, kind of hunker down in there and then pull shielding around. That's an extraordinary step in a tiny little Orion capsule. Not a lot of space in there. In the end, what they decided the best thing to do was take mass and move it around the least shielded area of the spacecraft and then try to go about their business. Fortunately, we didn't have to deal with the storm of this scale, but we did have some concerns early on over hardware, and we'll talk about that very late. 1989, power grid impact affected 2/3 of the province of Quebec, Canada, just within 90 seconds after a storm sun arrived here at Earth. Took the power down the northeast part of our country, almost went as black as this. This is the NASA artist concept of the blackout in 1989. Imagine all this area of our country going dark for the space of the storm. That's the heart of our commerce, right between there and out on the West Coast. That's important. So we don't want to see that happen today. We struggled through that event. It was a good thing that Canada knocked offline within 90 seconds because it didn't damage their equipment. It just put it out of whack and knocked it offline. They could get it back up over hours and a few days. What happened in New Jersey was they were weathering the storm. So the transformer was overheating. Eventually it got charbroiled. It no longer was functional. That's a problem. That's damage, right? That's significant damage. In fact, it's getting loss of power, but if you damage the transformer, the relying for them, now you have a compounded effect because these things aren't made here in this country. They're not this my size. They're huge. They can take up this entire room. They're shipped in from overseas, built overseas. So if we have a catastrophic event like this happens today that affects a large chunk or chunks of our country, we need to be talking about something beyond hours, potentially days to weeks. And then just imagine a lot of things you talked about when you're involved with their association with the chapter. People like an impact. Health service, water utility, gasoline, fuel for generators, they're going to run out. Traffic lights don't work. People can't get on the phone, which we're tied to these days. These things ain't going to work. People are going to not be happy, and there's going to be a lot of social unrest. The historic benchmark event, the one that we are concerned about, the one that the government plans for, is the Carrington event, as it's called, in 1859. Called the Carrington event because an astronomer named Richard Carrington was observing the sunspot, making a sunspot drawing over in England at the observatory. This is a sunspot drawing. You can find it on the web. Pretty cool. A big, massive sunspot group. They happened to put longitude lines on here. We still know that was a pretty large sunspot group. Then he drew these little white lights. That's what you can see them. That's what these little kidney bean shapes are. Little white lights that showed up around the sunspot group. That's extraordinary. He did not know it at the time, but what he observed was something called a white light flare. Basically a solar flare, this burst of energy I'll talk about it explain in a bit. That was so bright, it outdid the brightness of the sun. That, noted on his drawing, the date, about 18 hours later, the sky lit up in the world. So much so that people here in Colorado, I think miners, thought that daybreak was breaking. Must have been a cloudy night, but they started waking up at like 1 in the morning because they thought it was warning. Not warning. It was the power in this aurora was so strong and so bright that it actually bright things up at the surface they could see. People didn't know, they thought the sky was on fire, and so the islands would never normally see this kind of thing. What happened technologically is very critically important to us today, why we have great concern about something like this. Imagine if I shut off the lights in here, just flip the switch, turned it off, but they stayed on. That's what happened with these telegraph operators. They didn't have alternating current there, and they had direct current. They had batteries to power their systems. All of a sudden, these communications across these copper lines, these telegraph lines stretching miles and miles and miles. They were having discussions, slapping their metal plates together, sending Morse out, and then talking about their problems. Batteries were sparking. Some stations started on fire from that. So many garbled communications, they decided, okay, let's disconnect the batteries. But point power, they could still be hearing the conversation. From the natural current that they didn't know what was going on, that was on a line, allowing the signals to still transmit across the line. If that happened today on our electric power grid, without any mitigation measures, without any protections at all, we'd be in a world of hurt. We're pretty confident that there would be some kind of collapse, some kind of bulk transmission failure. But fortunately, as we go off track, this talk didn't blame it. This is being thought of today, when maybe it wasn't being thought of 20 years ago or more. More recent stuff, just getting into the 2000s. Soldiers were killed in Afghanistan in 2002 because just of a communications disruption. They were on a flight on a helicopter going into and trying to take the kill, I believe it was. They weren't aware it was occupied by the enemy. They were trying to be communicated to about that to stop the mission. They didn't get the message. Why? Because communications disruption from a solar event, from a space weather event. And most three of those soldiers were killed. Very tragic situation. In October of 2003, transformer grid damage in Sweden and South Africa. Well as a loss of a satellite that Japan had in space. Space weather is fascinating. People don't normally hear about it because there's so many actions being taken to try to protect things. And we don't want to hear about things like this today. 2012, we think a Carrington level event will have the sun. We happen to have a research satellite, a NASA satellite was going around the sun. It happened to be in a position 90 degrees ahead of Earth's orbit. And this CME was aimed right at that satellite. And we know from the field strength of that solar storm, that get that satellite measurements it had, we know that this probably was a Carrington type level event. But it wasn't aimed at Earth. It was aimed directly ahead of Earth. When you look at this picture here, here's Earth, here's the sun. CME was going out this way, more or less. If that had been aimed at Earth, we could tell a full year story about how that could have been a Carrington level event. We'd talk about it wasn't a Carrington level event. Simple space weather stuff. Not even high up on our nose space weather scale. If you're not familiar with it, you're going to see it here in the next couple of slides. But this was a minor storm. Not even moderate, not even strong, not even severe or extreme for that matter. 38 of 49 Starlink satellites that had just gone up to go into a lower orbit, and then they were going to rise a little further after doing it. They put up in the atmosphere within 2 days. SpaceX wasn't thinking about space weather. They're just throwing stuff up into space like other companies are right now because it's become so privatized in many ways. Guess what? Now they pay attention to space weather. They were dealing with that storm that we had in 2024, and they've been dealing with one ever since. And they planned for these things a little bit that we have. Just more recently, just this year, the Martin Luther King Day storm. It's kind of funny how so many of these storms happen around the holiday. We had the Veterans Day storm of last year. We had the Martin Luther King Day storm. Who knows what's next? But they go on the Independence Day storm of 2026. But that storm I'll talk about in more detail in a minute, because that storm was impactful, but it could have been a lot worse. You understand why there. So what is space weather? I've been talking about all the historical events here already. What exactly is it? Well, it's what's taking place in the sun 90 miles away. You have that huge vacuum of space between the sun and the Earth, and ultimately not gearing around the planet. Now, when I talk to emergency managers, because guess what? Emergency management thinks about space weather now. They never used to do that. I've been making a very high pitch in my role as service coordinator in SWPC to work with emergency management, because the rest of my weather service meteorologist colleagues, they don't understand space weather. I'm trying to get them smarter about it because they really should be talking to their city and county and state emergency management team, not me. But I'm still doing it because they're still trying to get smarter about how to talk to them about these things. But when I do talk to them, I tell them it's a very low risk, but it's a high to very high impactful event that doesn't materialize. So bottom line, you probably should at least think about having your hazard risk assessment plan. Has there been stronger events in the benchmark storm? Very likely. One's called mountain events. These things have been known to tree rings by scientists and the way I don't understand it, but essentially bottom line is there's probably been storms even more significant on the sun that we haven't seen in over 100 years. Thousands of years past. Our sun can do pretty substantial effects. Now, it can affect so many aspects of our technology, and this just continues to grow. Until the storm in May of 2024, I had no idea that my brother-in-law in North Dakota cared about space weather. He's a farmer. What do they care? Oh, they use GPS today. They use GPS precision guided tractors when they're planting seeds and spraying herbicides and harvesting crops. That storm in May of 2024 took many farmers offline. They didn't know what was going on. John Deere and other related companies are getting all these phone calls. They finally had to issue a statement saying basically, what, this is a space weather event. You have no control on, we're working on the situation, whatever. So from farmers in the field to aviation to drone operators, to space launch to astronauts in space to Olympic power grid, whatever. These are all concerns about space weather. Guess what? Rail in Europe has to care about space weather. Rail. Why? Because it's an electric system. So not only are they concerned about power outage, they're concerned about currents that could change a red signal on the track to green. It can happen. They have a study about it. So they have to plan for space weather. Rail, we don't do that in our country. It's no on this, we do on whatever control they have. It doesn't work that way. Yes. That could change though. And then suddenly we maybe provide you support to rail. This just continues to grow. We have to think about drones. We got carriers delivering packages by GPS coordinates sent to somebody's house. Some of these storms have caused packages to be dropped in stuff in fences or other people's property. You don't have to be accurate within a centimeter like the farmers do, but you got to be accurate within, 6 to 10 feet. Otherwise, you can get dropped in the neighbor's yard. And you would think so because of their GPS, but they have a lot of redundant systems. These little sensors that sense things on the road and where the border, the white lines are and stuff. So, no, we don't think so. But who knows how they want to change that. But right now, we don't get a say. I want drone. Yes, drones, GPS plugged in, or they're trying to communicate with it at a certain frequency is affected from some other event in the sun. And that sudden disconnect from the signal could make it quantum really quick. So yes, drones are a risk as well. Although not as much as one would think, but they are a risk. And they're being so much used more today that it could be almost run out of any other real. I mentioned it once already. I'll mention it replaced on it again. We're lucky. We're lucky right now. We're lucky over the last several administrations. Why? Because space weather has been considered more and more. The current administration really has a focus on space weather, more than in a very helpful way, more than one you can hope for, really, because not only is the space weather added to one of the executive orders that came out, and this is talking about state and local preparedness, which is a good thing. Basically telling emergency managers and our responders to prepare for certain things. At the time, maybe it was to take on more responsibility with FEMA. But now, because of the executive order, it actually says space weather in there. Think about space weather. I've got even more requests from emergency management. New York City is putting space weather in their hazard risk assessment plan for the first time ever. I've been working with them on that plan. They spoke at our recent space weather workshop. As a matter of fact, I had a pen and speak. Even better, space weather is getting added to the National Risk Register, which is part of the same executive order. It's going to be considered a natural hazard, as it should be. Space weather is a natural hazard, right? It's something emanating from the sun. And I think part of that has that risk assessment process for the risk register. So it looks like space weather is going to make it in there. It's making it through all the different experts on what scenarios they should be considered and planned for in these events. So once again, a really good thing. And this stems all the way back into the first administration when they had Executive Order National Resilience. Yeah, it was put in electromagnetic pulses, which is not space weather. That's like nuclear detonations. But geomagnetic disturbances is part of that executive order. So space weather is actually in there. That sparked some of the support we already do for the grid. Previous administrations have done the same thing, adding space weather more and more. So the good news here is that space weather is still getting the concern that it should be getting and the attention that it should be getting. Here's an example of what we're doing at SWPC that we weren't doing over 20 years ago. And this continues to grow. We work with the U.S. Air Force and Space Force now. Every day we talk to our colleagues in the Air Force because they're doing space weather for the Department of War and Air Force concerns, national security stuff. They take our forecast information and they tailor it to strategic defense needs, if you will, or war battles that we're in concern. Space launch. These and others are constantly coming to us now for space launch criteria. I was telling Daryl here before we started that we're already working on specific decision support, additional service, what decision support is. If you think of us just sending out forecasts and warnings and stuff, that's not decision support. That's just our standard support. But if you're actually picking up the phone, if you're making a product for a specific thing, that's decision support. We're going to do that. We're going to have our mission plan in September. We're already working. We did it for Artemis 2. We've done it for other things. We talk to our colleagues at NASA, the Space Radiation Analysis Group, every single day as well. Why? Because of the ISS, the International Space Station. Matter of fact, this morning we did an additional call from early because there was a scheduled EVA spacewalk today. I don't know if it went off or not. I have probably is. But we haven't talked about all these things right here for astronaut safety concerns in that spacewalk. Transmission operation centers. We talked to some even at lower levels of activity in Wisconsin and New York State. Air traffic control in Oakland. We talk to them when we get to certain levels of activity. They disrupt communications to aircraft out over the ocean. FEMA. We get to the 4-hour scale of events. We're communicating directly to FEMA. And now we're even talking to the White House Situation Room to a point of contact there about space weather events, especially if we're talking about the potential for a fine. It's how we're going to scale. And we're doing so much more when it comes to the public and media. You'll hear a lot about that as we go as well. So where are we at? How does space weather work? Why do we hear so much about it over the last several years than we did in previous years? That's because the sun operates on a cycle. Roughly every 11 years or so, it goes through a period where it's a minimum of activity into a maximum of activity and back down to a minimum. So on this plot here, you can clearly see this cyclical pattern. Solar masses highlighted at the top, and each of these are a solar cycle. So we're currently in solar cycle 25. This is kind of where we're at in the cycle right now. We're starting to come down. But what do we know historically about space weather storms? Some of the strongest ones in history have happened as we've been coming down from solar events, just like you are now. The largest solar flare we have in the previous solar cycle happened 2 to 3 years after the peak of solar maximum of solar cycle 24. The Halloween storms in 2003, we were already having spotless days of the sun. 1 to 3 years going down from solar maximum. And that was the strongest storm. We haven't seen a storm that strong until May of 2024. August 72, 2 to 4 years after solar peak in that maximum. So what am I getting at here? As I said, we're still ripe for extreme events to happen, potentially in the suns, the rest of this year, next year, perhaps even before things really start to settle down. We'll have much less risk. Space weather can happen at any time during the solar cycle, but when the sun looks like this, it's more likely when it looks like a cue ball with nothing on it, you're a lot less likely to have things happen. The bottom of the chart, the higher frequency fluctuation than the depth. See some of that? So, let's go to the top here. So, solar cycle 25, the one you're seeing here, you find a spot on our webpage, actually, the solar cycle progression plot. And what you're seeing here, it's a monthly update. So, early in the month, we get the latest update. It's a sunspot number for the month, what the average sunspot number was, the peak sunspot. And you have this fluctuation because it's always a roller coaster ride. It's not just you're going to see activity constantly spike up and then stay up and slowly come down. It's up and down. It's just the way the sun works. So there's a period of time that things we're less sunspotty on the sun, and then suddenly you got various sunspotting again. And you can see it is next year as we gone along 2025, and then suddenly we had some pretty major storm in November. And then they're starting to come down again. So who knows? The purple here is the forecasted remake of the cycle. So even the forecast is trying to show that, we're not quite done yet before we really start settling down. And this happens because the sun's polarities, its poles, magnetically flip roughly every 11 years. So just because of the way the sun works out here on Earth, it's pretty stable. We know it's undergoing a possible change, but those happen thousands and thousands of years. But the sun here now, it's probably every 11 years. So here's the smallest space weather scale. If you're unfamiliar with it and you have an interest in anything you're doing, your work, your profession, or the UN, association with UN, get familiar with this scale. You can have activity below the one on the scale that's in work. We actually send warnings out of some of that stuff. So think of it like tropical storm and a hurricane. Tropical storms are still deadly. They can still be very damaging, cause massive problems. But they don't warrant hurricane status because they don't have that level of wind. Similar thing here. We have things that happen that don't meet a scale, but can be very problematic. But when you get to a certain level, okay, now more snow, space weather attribution, we start to speak in terms of the extreme levels of activity on that 1 through 5 scale. These are kind of effects-based things. So the R scale relates to radio blackouts, but it's only talking about high-frequency radio, not every communication band. Like the solar radiation storms is the S scale, that relates to solar energetic protons. And then you have geomagnetic storms, that's the G scale. We'll talk about all these things what they all mean, but by now you've read through some of the dates. What these can be concerned for. What do we send out? Well, besides the level forecast and other products, when it comes to those space weather scale activities, we can't do a watch or a warning for a solar glare related to the R scale. Why? A watch would be so we're solar massive, we have a watch out of the day for months and months and months. So soon occurrence. We don't do a warning because we have no way of knowing that a solar glare is imminent. We do not know that one is about to happen. We can forecast the probability that one will happen and how strong on the scale we'll get to 3 days in advance. And we have no way of knowing that one is imminent. So all we do is alert. And alert for us means that it's happening. A warning means it's imminent. A watch, just like other service, means it's likely a good possibility. The solar radiation storms, same thing. We don't do a watch because there are periods of time where we can have a watch out in the days. So we just focus on the warning, and that's only with gust 1 or higher. We don't do any additional warning. And then for alerts, we alert every new level that we meet on that scale. For geomagnetic storms, we do a whole thing. Why? Because they don't always happen, and we can get advance notice out there because of the way they analyze and what causes geomagnetic storms to happen. We'll send out warnings up through G3 basically. We stop there and just call it KPS7 or G3 or greater if you that. And then we alert every single level of the reach. We don't get into more details about the breakdown of how that works here. Throughout this talk as well.
How are they detected?
How are what?
How are the solar events detected?
We have observation platforms in space and observatories on the ground. So right now, just about everything that you've seen on this list, we probably get that early word from a spacecraft. All the instrumentation to measure these things are for Kamala Go satellites. They have the space weather package on there. And they're observing the X-ray flux that we measure for solar flares that relate to that R scale, and they're measuring energetic protons that relate to radiation. For geomagnetic storms, that Earth-based observatories that have magnetometers, it's kind of like seismometers that measure earthquakes. There's magnetometers out there around the world that measure shifts in Earth's magnetic field. When you calculate some of these together, you get a general idea of how strong of a reaction will happen to the geomagnetic storm. So that's coming from those. But you use spacecraft to detect the events that cause those, and I'll show you why and how that's done here. So,
To be clear, it's over again. In that our magnetic.
Yes. Yep. The magnetic energies from that arrival of the event of the sun can interact with Earth's own magnetic field, and that drives also the natural currents that flow around the planet. into higher levels, and that's when you're getting on the different systems. Yeah.
It has the gel and the manual provided to follow that needed to create some power at some transformer.
Yes.
Working through the Earth's magnetic fields.
Yep, it all starts kind of in there and interacts and causes the geomagnetic induced currents. The equipment, the space weather equivalent of EMP, but not that dramatic. That's what gets on those high voltage transmission lines, gets into the transformers, and overheat that because it's causing harmonics in these things of the engineers that can cause the galaxy system. And it also changes our atmosphere structure, our atmosphere, which can affect many different communications and GPS accuracy. So yeah, geomagnetic storms become the most broad-ranging, impactful event. It's a little bit more limited on what reaches to a radiation storm. It's very limited for what the solar flare itself causes. And let's also think about timing of these deaths. A solar flare is speed of light. We see it on the GOES imager. It's already, the impact already here, but it's on the daylit side of Earth only. The effect it just does is only on the daylit side of Earth. And so there's a misconception a lot of times that, oh, we see a solar flare, we're going to see something have a storm in 8 minutes. No, we already have it. We're already having the effect because it's made its 8 minutes speed of light turn. Solar radiation storms, they're a little bit slow. We have a little warning time here. We don't know when one of these are going to break out either, but we have a little warning time because it takes time for them to get here. They can get here as fast as 15 minutes. The energetic particle from the time we see the solar flare. Almost speed of light. But there is warning time there. Thanks to a sensor on the NOAA satellite and sensors we have on other satellites a million miles away, we can get an idea that maybe one of these is about to arrive here at Earth, or is arriving, and we can get a warning now. And then geomagnetic storms, we're using spacecraft to measure the event that causes, that leads to the geomagnetic storm, that gives us the ability to put out a watch and estimate a level of that watch. We don't try to do a G5 watch, we stop at a G4 and call it a G4 greater watch.
And the more time, it can take longer for the Earth magnetic field to get affected by the solar event.
Once it arrives here, it's instantaneous, but it can deviate. And I have a really nice light where it'll help explain what I'm talking about there. Is why you can have a storm before a going bird, that there's nothing happening, and all of a sudden something happens. Which makes it very difficult for us to forecast, right? Because there's so many nuances when you're dealing with kind of forecasting and that. I mean, it's hard enough when I was doing mainstream meteorology to forecast a arrival of a severe storm if it was actually going to hit like the missile complex out in North Dakota while I was my Air Force days. Hard enough, just 50 miles or 100 miles, it's still going to exist or not when I put that warning out. But I tried to do it for 90 miles. That's a lot. That's pretty hard to do. So let's talk about the R scale. Solar flare. What is a solar flare? Solar flare is a sudden burst of electromagnetic energy that affects much of the electromagnetic spectrum that we measure, but we measure these in X-rays. Why do we do that? Because the X-rays are what are impacting our outer atmosphere, that ionosphere on the daylit side of Earth. It changes the structure so that high-frequency radio waves that normally bounce off the atmosphere, they craft off there, they get absorbed. They don't do it. Aircrafts do these HF communication when they're flying across the buildings. So they still need to be aware because they often report communication prompts on HF, so they're still using it. Talk to HEC on over long distances. So if you measure these, as I mentioned, with an X-ray flux sensor on the NOAA spacecraft, and it also imagers that allow us to get images every 5 minutes or so to look and see where these flares are taking place. Now, a solar flare does not matter on the sun where it happens. As long as the sensor sees it, like this one right here, at or beyond the limb of the sun, that effect is happening on the daylight side of Earth. Doesn't matter where it happens on the sun. But on the dark side, and we don't see it, well, obviously, can impact the thing. But the sensor sees it, the atmosphere experiences it, and the effect is there. If it's dead center, there's no difference. That event would be the same as right there. When it comes to high frequency radio problems being events. Now, when you take space weather and you combine it with terrestrial weather event, this can make the situation even more dire. So in 2017, the strongest solar flare we had in that cycle, a couple of years after solar week, happened to be our hurricane season. in September. And as hurricanes had devastated the Caribbean islands. So FEMA had a big response set of down the Caribbean islands. And they were using high frequency radio and ham radio to communicate all across these islands, right? There wasn't lines stretched out between the islands and the mainland. They couldn't do it because that solar flare, this red area, made it impossible to communicate on HF radio. And this lasted, normally solar flares are impulsive, meaning they last just minutes to tens of minutes, but they can last hours. This was one of those that lasted hours. It stayed pretty strong for a long time and come back down below levels that didn't affect the atmosphere anymore. So think about that today with the power grid. Major heat waves, they seem to happen more and more frequently in the news, right? You get a major heat wave going on, the grid's already stressed, they're already trying to keep the idle transformers cool. So now you have a heat wave. We have AI stations being put up in centers and servers, right? Using pulling massive amounts of electricity. Along comes an event from the sun, not a flare, but something caused a geomagnetic storm. You escalate that into the mix as well, and now the grid has to be something.
Is AI also being used to help in detection?
Well, yes, we're working on that. AI will be part of that somewhere, and we're starting to explore those possibilities to help us, not only with detection, but with forecasts and verification and all of these things. We learn more and more about space weather impacts. Some things we just flat out can't forecast, but fortunately we kind of watch for them. And we watch for this, thankfully, to our Air Force Space Force colleagues that have a radio telescope network, and they monitor specific radio frequencies from the sun. Why? Because communications matter. Remember the soldiers that were killed in Afghanistan? Communications matter. Well, they had it us in the pedestrian civil world as well, right? So in December of 2003, so we weren't in the peak of the sun, we were working our way up. December 14th, as a matter of fact. There was an event that happened in the sun. It was just I think it was just an R2 level flare, so nothing extraordinary. Lower end on a scale, but there was an associated event with it that almost brought air traffic to a standstill across the country. This was something called a radio burst. So the sun is a giant radio transmitter. And sometimes an event happens in the sun and it sends massive amounts of radio energy on specific frequencies. There are 8 frequencies that the Air Force measures for us and reports to us. 2 of those bands are in that VHF, UHF range, which are line of sight systems. So when aviation is flying across the oceans, they're using satellite communications or high frequency radio to communicate their traffic control. When they're flying across the domestic United States, they're using line of sight systems. So higher frequencies, VHF and UHF bands. But what happened on that day was that this solar flare right there caused aviation has come to almost count the ATC 0 cleared. If you don't know what that is, all they're going to tell you is the last time that happened was in September 11, 2001 during a terrorist attack. Stopping aviation. Why? Because pilots could not talk to air traffic control. They were changing frequencies that was almost impossible to find frequency early. They were in that line of sight. Pilots stay ATC and back and forth. Well, what happened is now a radio burst detected that got to be 1 million times stronger than what's normal background. That's extraordinary. We had never seen anything like that. We asked one of our forecasters who's been with us for a long time. He had been an observer, even in Australia. He was a former Air Force guy as well. He had never seen one that strong. I actually called the observatory to report that burst and asked them, are they sure about that information? They said, yes, we are. Nobody had ever seen one that strong. So what did that do? Well, that caused radio interference on those frequencies. What exacerbated the situation? It was daylight. It was dawn to early morning. Now we were out in the U.S. It's winter, so the sun is even lower in the sky. It's almost a solstice, right? But what happens is the sun has to kind of be in the background somewhere to disrupt things like that. And it was lower in the sky. It was earlier in the morning. Air traffic's flying around and they can't talk for up to 10 minutes. So we cannot forecast these radio burst events. We can only see them and notice and maybe get a word out like we did in this case to let everybody know this is not a cyber attack. This is not a technical equipment problem. This is a space weather event. So if we were dealing with that situation, imagine what our military colleagues were dealing with at the time as well. So yes, you have to think about these things even today. I've been talking with the Federal Aviation Administration, what I did here recently about space weather and taking the radio burst, because this wasn't the only one that's done this. There was an even stronger one that happened later on, about 2 years, 1 year later, that was even worse. The difference was daylight was out over the ocean, not over the U.S. Right, so solar energetic proton mass, the S scale, the solar radiation scale. Most people don't have to care about these or worry about them because this is going to be an impact to satellites at higher orbits like geostationary, geosynchronous orbits. This will be an impact to spacecraft and space watch platforms going out into space, and astronauts, even aviation, because what do you say, basically, radiation exposure risk to aviators, air crew members, and passengers at higher altitude near the polar region. So what are these? These are solar energetic protons, so particles now. So solar flare is burst of electromagnetic energy, speed of light stuff. These are particles now. And these particles can penetrate things like satellite components and get the electronic circuitry and cause erroneous demands to happen. They can get into your tissue and cause radiation exposures and damage to the DNA, which can affect, obviously, astronauts in space. Pilots, I mentioned, yes, up here in the polar regions at higher altitudes, these noise of their works can cause issues. So we want to predict these and forecast them and warn on them. And aviation takes note if they think that they will decrease altitudes, they will do. Well, you'll see in the case of November, they just flat out canceled flights, which was extraordinary. But they can agree these to run flights literally equate away. So once the big one, the coronal mass ejection, the CME, this is what leads to the geomagnetic storm. This is what coronal mass ejections look like. So white circle represents the diameter of the sun. There's the sun. The black circle is the Occult disk, kind of the artificial moon placed in front of it. And then you see the outer corona of the sun. Normally it looks great, no issues. The clay, and I just missed it. There we go. But then it can go blasting off from the sun at extraordinary speeds. What is that? That is basically a piece of the sun. You bring it out into space. Coronal material flying out at very fast speeds in most cases. We have a coronagraph, which is a symmetry in space, several of them now, located a million miles from Earth. And then on those spacecraft, there's 20,000 miles from Earth now as well. So we're getting a lot of good imagery now. If you look at these CMEs, every time a forecast is a CME, like this one, or this full halo, as we call it, or a partial halo like you're seeing here, we're analyzing it, we're embedding the parameter of that CME, trying to determine speed and direction, and then we'll ride the Earth. And this is the model that we input that into its WSA envelope model. And then you look at the result. So the center is the sun. The side is Earth. This is just the wedge looking at it sideways. This is looking down upon the solar system. And then we can watch these CMEs propagate out into space. And then we'll do several of these runs to determine whether or not they're going to hit Earth, because little differences in how we analyze these CMEs, where we put the perimeter or where we put the main ground material, can make a massive difference about whether it actually shows up as a hit Earth or when that hit would actually be. So there's a large measure of uncertainty even today, until we have better models for us and better tools to help us map these CMEs a little better. When they arrive at Earth, we get the thing called the geomagnetic storm, that G scale. The geomagnetic storm is the result of all that material interaction, magnetic fields, solar material, charged particles, and they wide in along Earth's magnetic field lines, and they cause all these issues. So you can have a CME arrive, punches directly into Earth's protected magnetic barrier. That alone can cause things to happen. But then, if things become more favorable over time as that CME continues to pass, they can interacting more with the magnetic field lines and cause a pretty long duration geomagnetic storm. We put the watch out based on that. This is important to keep in mind. This visual imagery, we know nothing about the actual speed, what it really is. We know nothing about magnetic intensity of the magnetic cloud getting carried in that CME. We know nothing about it. We're just observing it and saying, okay, so that's how we put our watch out. So we can put a G4 greater watch out and it's based only on visual analysis. We really don't know what to expect until it gets 1 million miles from Earth. And the satellite or solar observatory out there can give us information about the solar wind speed, magnetic field intensity, magnetic field direction, which you're going to find out how important that is here in a bit. That's what you put out a warning. That's kind of our first warning point. You know, the CME's arriving 1 million miles away, probably going to hit Earth in the next 15 minutes to an hour, whatever. If we think things are favorable, we'll get warnings out right away. Otherwise, we may wait till it arrives at Earth and then watch the magnetometer how they act and put a warning out there. But the alerts are based off of the magnetometer and the 5 big G's out. So there's different ways to measure geomagnetic activity. We forecast KP, it's an index. You know, meteorologists, we use indexes all the time, get the indices and indexes. Space weather is no different. Now, the KP index is kind of a planetary geomagnetic disturbance number. It's a 0 through 9 scale, so index. And each of those numbers, with the exception of 9, is divided into 3s. So you can have a 1M, a 1Z, and a 1P. The low end, the middle, and the high end. So the scale, when we get to NOAA space weather scale level, we're at the KPF5. That's a G1. So a KPF5M, KPF5Z, and a KPF5P are all a G1. It works that way with each new level up until you get into a G5. A KP and G4. A G4 actually covers KP8M through KP9M. A KP9Z, that's the end of the index. It doesn't go any higher than KP9Z. So you can have a KP9Z that's here, or a KP9Z like in Carrington event that's 3 stories above my head. We're working on that. We want to be able to differentiate that. So we're working with Power Grid and another customer. So a G5 is the top end of the index, a KP9Z. This is what we're doing with the power grid. Just power grid. You saw an overall example of all the people we're talking to. For the power grid alone, we get to a G1, we're talking to Wisconsin and New York independent system operator. Why do they want to know? They're not going to have any negative impacts, but they may stop maintenance, precision maintenance on the line in the system. They may divert a human resource to monitor integrity of transformer or something. We'll do it again for a G2. But G3, in the middle of our scale, we initiate a conference call with the entire power grid of all over the America. All the southern Canadian provinces, all the mainland United States, even a reliability coordinator, that almost any of them, they get on that phone call. We had a mandated this by the government through the Federal Energy Regulatory Commission, which is the Interconnected Power Grid, the North American Electrical Reliability Corporation. That's who we talked to at a G3, just in a G3. Not that they're going to see any major impacts either, but now we all want to be aware because a geomagnetic storm can escalate quickly. We can be just sending out the alert for a KP of 7, G3, and a couple minutes later, we've already reached a KP of 8, and then a KP of 9. This happened. So we stopped the warning to KP of 7 because we don't want to get too redundant. And then we go with that. But basically that G3 is the starting point, and that's why they picked that, is because they know it can escalate quick. They probably aren't going to really see any major impacts or effects, I should say, until we get to the G4 levels. They have seen pretty good ones at G3, depending on where they're at in the country and what's else is going on. But G4, they're going to start to definitely see things on their systems. You get to the G5, they're dealing with the situation. Doesn't mean it's going to be a fail effort, but it means they're dealing with it. Operators are working hard to maintain integrity of systems.
So once meteorology gets to the point, what can they do to mitigate potential?
Well, we learned a lot with the May storm, and I'll give you more details on we get there, but generally they like to call it precautionary or preventative measures or conservative measures. That can be a wide variety of things. It can be things from getting additional transformers and maybe aren't at full capacity ready to take on the load. Then you high voltage transmission lines that aren't at full capacity for electricity and get them ready or in operations set. But that takes hours of notice, not minutes. What they do with just the morning minutes of notice, if we didn't get really advanced notice, is more like suspending maintenance. They have sent technicians out to the field to listen, actually listen and measure temperature and transfer. So if you hear unusual sounds, they're going to get concerned and check other things. Is there something GICs that induce currents from the storm causing these problems? So these are things that, in the worst case scenario, they can start switching things off, but they're not going to want to do that. We don't like that in this country, right? We like things flowing, so they're going to try to weather the storm.
He called to 1,000 elected consultants. And it said like the clearinghouse, and then they send out the word to all over the country.
The liability coordinators are one that clearinghouse. That's who gets on that V3 call, and then they send information out on their comm systems to all their transmission operations centers and their area of responsibility, and they just make that out and how they do. These are individual calls, so New York thinks it's operators and control system that falls under the NYIS, the system maybe or something. Wisconsin is like a transmission operations center. Just like, I don't know who it is here for Boulder, who services Boulder, but it's kind of similar at a similar level. But they want that phone call straight up. I tried to get rid of it. They don't want to get rid of it yet. Not sure why. New York ISO is getting the word either directly through that GMD hotline call, but they want the early notifications as well. They stopped asking me to phone call with G3 because I know they're getting the word through that call, which is a good thing. Wisconsin is not. They still want, we still have to actually call Wisconsin. And that gets redundant on the broadcast stuff. Because not only we're doing all these calls, we're doing all the other stuff I showed you earlier. So one day I'll be like, don't know, we're actually having a coordinated exercise on time more detail about with the power grid in August. So again, comes to SWPC, me, our guys, so Wisconsin going to be there, and a bunch of others that you see out here. They're going to come down here to our center, and we're going to work together about better service we can give them, understand more about what they actually need and how they use that information. So we're going to block. It's the GICs, the geometric use currents that the power grid cares about. They don't necessarily care if it's a KPS7 or a G5 or whatever. They care about the GICs. We have a model. It's called the geologic field map. This has been done. This is based on geologic surveys that have been done to understand the resistivity of the rock that we all live on, and involves orientation of transmission lines, because that makes a difference. Proximity to salt water makes a difference. So this model is trying to take all that stuff into account and spit out a number. Now, you may not be able to read it from back there, but this is usually going to show up in millivolts per kilometer, so 1 over 1,000 volts. You get to 1 volt per kilometer, they would be noticing things on their system. Not necessarily a problem, but they're noticing it. You get to 10 volts per kilometer, they are definitely noticing it, maybe dealing with something. You get to 14 volts per kilometer, they could be dealing with a problem. You get to 15 volts or more per kilometer, that may cause a bulk transmission thing. The storm of 2024 in May reached on this model, we said about 10 volts per kilometer. The 1989 storm, the Dot Power of Canada, reached 14 something per kilometer. International collaborations, they grow. And they're growing, and they're growing. 20 years ago, we were the only ones really doing this. We've had people from the UK and that office come here and train with us. We've had people at the Korean Space Weather Center. We had forecasters go out there to train them. And we're doing this. So more and more centers are out there. Many other countries are doing space weather now. Do they have their own space weather observatories in space? No, most of them don't. They're using our information, and that's fine. It's like a collaborative effort. It causes joint efforts to be undertaken to get other spacecraft out there and investments that we just can't handle on our own. But yeah, the U.S. and Space Forces, you got NASA, Moon to Mars program, the Met Office, the Bureau of Meteorology in Australia. These two, Met Office in England and the Bureau of Meteorology in Australia, we actually have a communication channel with them to their space weather forecasters, but we coordinate. So if we're talking about a CME from the sun and we're like, what did you get for the model results? They're doing model runs too. And we're all coordinating. And then we all make a decision. We have the final say on what we're going to do. They have the final say on what they're going to do. But we don't want them saying, oh, this is only going to be a G1 storm. And we're saying, no, it's a G4 or greater storm. That ain't going to happen today, unfortunately, because of this international collaboration. So this continues to grow. And Matter of fact, the European Space Agency, I think I have it on another slide, but I'm saying now, and NASA are working on a joint mission to go to another United States at a very needed location to kind of give us a sight of the sun, of ones that I'm rotating currently view. And then Korea's working on a mission to go out to the opposite point around the sun, also a million miles of the Earth, basically, but of what's rotating ahead of us on it. So you'll get another sighting. So down in the future, maybe 2 solar masses from now, we might have a spacecraft on each side of the sun and one like normal here between the sun and the Earth. That's huge. That's going to make our forecast into that WSANO model, whatever model we have, so much more precise and better. Because right now, it's just the direct view. We don't get good sightings. I talked about Surrey. That's the Vigil mission, the one going out to the L5 orbital point, which is that side view I was talking about. L4 is the one that's ahead of the Earth's orbit. That's the Korean Space Agency doing NASA mission. They've been looking and discussing how to do it. This one is definitely going to happen. The joint Korean one, we're not sure yet, but it's in the works. And then now we have the first ever dedicated, fully dedicated to space weather operations, 1 million miles per Earth. That's a NOAA asset that we have. It's called Solar One. It was called SWPO L1 as it was working its way to that L1 point, which is the one right between the sun and the Earth, 1 million miles away. But now it's being named Solar One, and it should be fully operational here in the month of June coming up. And there's a chronograph on that one as well. So we're going to have, that's the first time that's happened with Big Pun. No operational satellite that far away. So things are getting better when it comes to space. These investments are being made, and we're getting better in making for it. What might a Carrington level event look like unfolding today? Well, 2 years ago and before, I will tell you, let's get the story behind this here. Why? Because the only coronagraph we had was a NASA research satellite called Soho Moscow. 1 million miles per Earth in that L1 point, not ours. They could take the tracking stations that are getting chronographic imagery from it and said, no, it's time to track the probe over here looking at this asteroid. You don't get information for hours. Fastest a CNN can get here at Earth historically has been 15 hours or so. There's been times when that tracking you got for 15 hours. We could totally miss it. That can't happen now because GOES 19 has a compact chronograph on it. We get an image every 15 minutes. Solar One is going to give us an image every 15 minutes. They're going to be offset, so we should get an image every 7.5 minutes. So in the event we get an extreme fast-moving CME, we're going to know really fast. And we're going to be able to get early model results in within a couple hours because of that speed and our ability to do that. So yeah, now 1 to 3 hours after the event, we'll be able to see it's on its way to Earth. Within 2 to 4 hours, we'll have our initial analysis done, initial idea of speed, and starting to put the word out there. Within 2 to 6 hours, we'll be talking to the other centers about what we're seeing and what we're getting from results. We're getting coordinated effort out there. As fast as 4 hours from the time they see the CME, we might be able to issue a G-board radar one. That's a tremendous leap forward. That's what the power grid needs. They need hours to days of notice. You do ingredients and all the other works, but that's what we can expect now, thanks to these new spacecraft and observatories going up there. What might it unfold if we get a Carrington event today? Well, I'm talking about volts per kilometer. This is a chart from the USGS, the Geologic Survey, that was looking at potential for GICs and extreme historic events. These are the most prone areas in the country. Upper Midwest, my whole state of North Dakota, part of that, up in the Northwest, and along the whole eastern board for the most part, further south. I mean, even a place like Texas is actually a little more prone to the geology and what their requirements are for what to be planned for in space weather event. And by the way, this area is not immune. It's just the mapping wasn't done yet for that particular chart they put up here. But they've got some of this down in there. So what's the expectation? Well, seeing it arrive to Earth, we explode very rapidly up to the G5 level, seeing the favorable power grid people would be experiencing 50 or more volts per kilometer on some of their systems throughout the country. We could be seeing some potential catastrophic failures in these areas. That's what we're planning for, not National Risk Register I talked about earlier. We're putting in feasible that could happen scenarios that aren't science fiction. But even though they may be less likely, that's what they want to be ready for. So yes, these would be very dramatic. We'd be very involved, much more than we have been in the past, and we continue to be more so. What kind of effects might have been unleashed today? Besides just the power grid, well, now that we talked about already, GPS, they realized in May of 2024. And it started off, by the way, I realized how impactful. I knew GPS was impactful for aviation. I already knew that. I know I didn't think about the farmers. My brother-in-law called me up and I had a storm as it was ongoing. And he said, "What the 80s is happening here? What's going on? My GPS wasn't working today." So he already had an idea maybe it was causing it in his interaction with John Deere or whoever. And I was like, well, yeah, we've got a massive extreme geomagnetic storm going on. It's disrupting GPS. So I'm explaining it to him. So now we have to think about ways, not just to work public, but giving these information to help them. So one of the things I've been working on is with broadcast meteorology. So with mainstream meteorology, the Weather Service has a very core partnership with broadcast meteorologists, right? Who do people want to get the weather information? They don't go to the Weather Service page so much. They turn on their favorite TV person and they do the weather broadcast. And where they get their information from the National Weather Service. They interact with them on some of these comm systems. So I've been working really hard with broadcast meteorologists. I've gone to some of their conferences. I've given talks. I've done podcasts and webinars with them. And I mean, they're getting better. So much better. One of the first interviews I did was on a national level news channels, live interview. They put up a long NOAA space weather scale. They were talking about the wrong thing, asking me the wrong questions. They clearly had no clue what they were talking about. Today, they're asking me about magnetic field orientation in the solar wind. They've got smart. I've been successful in this campaign. My goal is to have them get on TV one night during one of these storms that's that significant and say, hey, everybody, we got whatever, trust the weather, but there's also an extreme geomagnetic storm going on. So your GPS system may not be working if you're out there trying to harvest your crops today. Keep that in mind. It may not be a technical problem. It may be space weather. How helpful would that be to them? Because it's a growing need. We're all relying on GPS. Satellite, we're relying on them so much. Starlink, low coordinate satellite system. These have limited fuel load. They can only burn so much. And when these lights kick into high gear, these satellites can suffer what's called drag. They're going through an atmosphere that's denser than it was. And it slows them down, and gravity starts going to war and burn up the atmosphere. They cannot create it. So collision avoidance has become a major concern today. The storm in May of 2024 resulted in the largest satellite migration in history. 5,000 satellites, give or take, were burning fuel, trying to stay in orbit in the right location at the same time, and nobody knew where they all were. You got competitive business. You're not talking to business B over here. Nation A is not talking to Nation B over there. You're using a map to try to figure out where it is supposed to be. And during a storm in the equation, you have no idea where they're at. They could be colliding. When you start a debris field that affects even more. You have, it's got to be domino like it back in space. Can't have that happen today. Space launch and aviation, we're doing more interaction with space launch. I think I mentioned it earlier. I'm really interacting with the launch coming up in September. We already dealt with Artemis. We dealt with one hack in November. You'll hear more about that in a minute. And then more and more work with the aviation industry. The May of 2024 has been called the Gann storm now. After Jennifer Gann, a well-known scientist in this field, she died very prematurely. Unfortunately, a big loss in the space weather community, but she did so much for us. So, in honor of her, it's been named the Gann storm. That may sound weird, right? But when it comes to space weather, that's a pretty golden ticket on it. And that storm lasted 2 days. We had G4 and G5 levels continuing, followed by a whole bunch of G3s. This was a long duration event. That's because it was like 7 CMEs all moving over Earth. One faster than the other, then it caught up and exacerbated and kind of compressed those fields and made it even stronger. But still, this was not a benchmark storm. This was our test. This was our test G5. We're not there. We're not ready for that pre-snoring because of my head G5 yet. We realize that. But aviation, look at the impact that had on aviation. This is the normal airflow across the Atlantic Ocean alone. Look how far south that is deviating. That's huge amounts of fuel. That's a lot more than whiteout that's out there. So these affect things. I already talked about harvest being affected. The North American Power. This is the first time we ever gave the clearly notification to the power grid. I mentioned that GME at G3, the hotline call, that's a requirement for a warning. That's just minutes of those. I took it upon myself when we put out that G4 radio watch, which, by the way, was the first time we've done that in like 20 years, that level. It's huge for confidence on broadcasters to how good they actually did that storm. I took it upon myself to contact my power grid contact and say, hey, I don't know if you know it, but we've got a G4 radar watch out, and you probably want to know more about this. Would you like me to do an early hotline call? And he said, thank you. I love that idea. Please do it. So I did it. So by the time I did it, they got 6 hours of wait time because the CNA ran about 6 hours later. But what was I able to do in that 15 minutes? Normally I saw calls very skipped. It's like 5 minutes or less. This one went about 15 to 20 minutes because it was me explaining what's about to happen, what we are expecting to happen, and this would be a long duration event, and answered any questions. And I answered a lot of questions for them. So they were able to get ready. They were able to get high voltage transmission lines ready to take on a personal current. They were ready and able to get transformers up and running that were at full capacity or to take on additional load. They can't do that with minutes. They do hours. They did all that. They came back to us after this event and said that we were indispensable in their, I forget how they worded it, but in their work to keep the lights on pace. And that may sound sarcastic and crazy, but yeah, I know how important was going to that. If we didn't exist, they probably would have been having some problems. There weren't any problems. Out in Northwest U.S., Idaho, Washington State, they had a high voltage capacitor trip from the storm. There was a power outage. Same timing, affected a couple of thousand people. They're not saying the power outage was due to that, but they are saying the capacitor trip was due to that. So you can't put two together and say maybe that was probably related. There were a lot of other high voltage capacitors tripped too, but they suffered no fault transmission failure. I think that's a huge credit on us as a center and what we did for the early notification. We got it 5 times 6. And then we put out G4 radar watch. It's now part of the procedure. This is it. I jumped ahead of myself. Some of the large currents they expected, some of them think to have in that area and want to stay alone. All of the other things that were reported to me by the Department of Energy and by the NERC were a lot of other related equipment issues, but no bulk transmission failure. That's a huge success story, is what that is, because this one could have easily done that. We're doing things like this. In addition to giving them a phone call, I give them a simple graphical plotting now. Believe it or not, today's simple is still good. I can't believe they actually like this. This was just an experiment that I thought would be useful to them. I provided them. They've asked it for me every time since. Because I talked to them, and geomagnetic latitude is what they talk to. Gives them an idea of where they perceive the strongest GICs, even though it's a simple box at this point. But we're going from this into something that's much more tailored and regional specific. And that's part of what that test bed is going to help us explore. So they get something even better, but this here was just a giant leap forward for them. And even one of the more recent storms we had, even though we were looking for a G4, they wanted this for a G3. So I don't know where we're going to. They love it, and it's very helpful to them. You know, one of the strongest storms that we've seen in 20 years, the damage storm of 2024, but it wasn't the strongest. They're talking about some of the values already, and I mentioned connecting that it's probably well over 15 volts to talk about. By the way, there's something called the disturbance storm index, DST for short. It's negative numbers. It gives you an idea of the total disturbance effect here at Earth on the magnetic yield. The larger the negative number, the stronger the storm. So May of 2024 was very comparable to the October storm of 2000, Halloween storm in 2003, the knock power out in Sweden and South Africa. The Barge of 89 don't quite as big significant storm. 60% capacity and like the hands want lead to that one. The 1921 storm, twice as strong. What would that be like today? The Carrington event, probably 3 times as strong. So in my mind, the spectacular one of the consequential the world got to see Aurora, yes, there were effects, there were some impacts, and they remained managed and mitigated. because it was the most prepared war to successfully mitigate extreme space weather storm in history. And it's thanks to all this work over the last 20 years in bills and legislation and what we do, observation success, science progress, and more. So this is my last explanatory slide, I think, and then I'm just going to wrap things up with the last few. So here's how complicated space weather can be. So here we are. We see a CME take off in the sun. We see it in the chronograph. We start using our analysis tool to measure the parameter, like outlining a circle, trying to figure out where things are, create the model, and pick the best result after doing these. And then we have to wait. We make our decision. Put out a lot and don't put out a lot. And then we have to wait for it to arrive a million miles per hour of the solar wind observer going out there. That's so you can actually measure the structure of the CME. What is it actually really like? So here's how this is so important. We put out those watches without having any idea of what any of this is going to look like. Zero idea. The only one we have an inkling of maybe is speed. That's it. You have no idea what the field intensity or the negative field in that cloud would be. No idea what the orientation is going to be. So along comes the CME. It finally arrives. You'll see a sudden jump. That may not look like one skew, but that's a leap forward by twice as much. Over here, we're getting up to about 5 times as strong. Just about as long, or even higher. So along comes the CME. Little nudge, nothing spectacular, but the magnetic field when it came in, anything above this orange line, that's 0. Positive numbers are above that line. That's the same orientation as Earth. So the way I always describe this is Earth's magnetic field comes out the south pole and the north pole. It's a thumbs up direction. Along comes the CME. If it's also thumbs up, it's like putting 2 magnets in the same clarity together, they're going to repel. So if it's the same orientation as Earth, you're not getting like the reactive CME comes in and starts to intensify. The magnetic field gets to 5 times more strong than the normal. That's significant. But the magnetic field, the direction is the same as Earth. Not a lot of reaction going on the G scale here. But then look, it turns out when opposite Earth's connected with Earth. Look what happened. Boom! KB shot way up. The kilometer response intensified significantly. We hit G4 levels with this storm. And then look at the magnetic cloud. It slowly turned back north, got above the positive numbers again, and it shut up. It just shut up. It was stopped. So we can have a G4 radar watch out like the down storm like we did. It could have been predominantly like this. We never would have seen anything like he did. And people would be looking at us, what the hell are you doing? You're screwing wolf and nothing happened. That's the problem we have with space weather. Until we can start to get an idea of what all this is going to be, well, we won't arrive a million miles from Earth, we're always going to struggle with this problem. Right. The most recent storm we had in January, Martin Luther King Day storm, 2026. Had one of the strongest magnetic fields we've seen in over 30 years. What's the difference? Look how fast that shot. Normal background level, by the way, is 5 nanotesla. This got up to, I think it's 90 something nanotesla getting there at the peak. That's the CME alive. Look how significant that was. A boom and then a giant erupt. But it was northward. When it first came in, it was southward. Right in here, at that strong level of response, 8,000 customers in southeastern Australia lost power. 4 high voltage capacitors tripped at the same time due to the space weather storm. People lost power down there. But then it shot back north to stay north almost during the brunt of that passage. I'm really concerned of what would have been experienced here if that had been all southward. So what I have here, the colors is the actual response. If that had been negative down in here, the purple is how we would have experienced. We probably would have seen a story and started in the Yanni storm. When we did our early notification to the grid, we got like 10 hours of notice on this one. And then once again, very thankful.
Did that include Australia?
No, Australia is providing their own support to their services. New Zealand uses our information quite a bit because the Bureau of Meteorology doesn't want to service New Zealand. It's space weather anyway. But yes, that's why we collaborate and coordinate with that. But yeah, I'm surprised at how many places around the world, even have Space Weather Center, are still subscribed to SWPC and IDSS service. So the Veterans Day storm of 2025, we had the most intense solar radiation storm that we've seen in a long time. Funny thing about solar radiation storms, you could have an S1 storm that's much more inductive than others because there's different energy levels. So the S scale is based off a specific energy level of a proton. It's called the 10 MeV level. So imagine me, I'm kind of an energetic guy, all right? Now imagine Clark Kent in his civilian clothes looks just like me, right? But who's got more energy? Me or that guy? That guy does, right? I'm like the 10 MeV proton. He'd be like the 100 MeV proton. Or the 500 MeV proton. Those higher energy levels, that's what this was. This experience of higher energy level proton. And just like over one of those, in the sense it was measured to 10, caused the Blue Origin one to scrub for 24 hours. That one. We were talking a lot to the launch officer responsible for that launch about this radiation storm, and then decided to scrub it 24 hours due to space weather. So this does impact things. 30 flights canceled. They were flying polar routes, international polar routes. They just flat out canceled the flight. That's disruptive to air traffic. That's disruptive to passengers, right? I couldn't believe it when I heard that. I was like, why didn't they just fly further south or at a lower altitude? But no, they just flat out canceled. And then a lot of aviation GPS problems reported about that storm. The Martin Luther King Day storm, I already talked about the depth in Australia. Once again, aviation was majorly impacted. And this is where I learned yet another problem today. I didn't know about this one. There are GPS precision approach-only airports. I didn't know that. I thought they had other names as well. Nope, there were flight diversions, including right here in Colorado, due to the GPS problems. They couldn't get into Aspen, for instance, that particular day. The GPS approach, for some reason, has one back to Denver, where they're going for. Seven in Idaho and Texas as well. So, yes, we have to think about these things for things we weren't really thinking about before. Now, we're working on more ways to communicate with the general public, the press media, but emergency management in particular, which is what this is designed to do. This is not more abused at this time, but if they ever come to me and say, hey, look, we've got a catastrophic response we're dealing with, you need something, we may produce this during the people will count. You're going to be working to ask to provide space weather information throughout that whole 45 days in cases of disruption of power in, or a disruption to GPS, or whatever, with enough mass response, there's a cataclysmic problem. So we may produce something like this during the People World Cup meeting. International civil aviation support. We're on our current 2-week stay. It just started Monday night. For the next 2 weeks, we're in the center of responsibility with international aviation around the globe to space loaded pilot. There's 3 other sectors. South Africa is supposed to come into the mix at some point, and they all deal with it for 2 weeks at a time and let our turn again. But there are specific space weather advisories in that whole aviation one. We continue our education outreach. I just did a tabletop exercise I was part of called FISA Shield, the Department of Interior. We were involved with one the day before the storm, the storm. The storm hit Friday. That Wednesday, just by coincidence, we were involved in a giant tabletop exercise with all the department level cabins. So our director was deployed to Washington, D.C., working at the cabin level. I was deployed down to FEMA Region 8 headquarters in Denver because they were to participate in FEMA region in the exercise. We started bringing real-time space weather. We started putting out these watches for these CMEs, so they couldn't have been more ready. We continue to work with FEMA. I'm always talking to the FEMA regions, giving them outreach briefings so that they're better, smarter on space weather. Virginia Tech, University, North Dakota, Minnesota. Many people and entities are coming to the university and looking to learn more about space weather because they know they got to think about this now. All these locations in green that I circled, those are states or counties or cities that have come to me and looking for more space weather information or getting it into their actual hazardous assessment plan. This is progress. We get all this whole country to be green. We are ready. I mean, it'll be successful, but we'll be ready. I mean, at the very least, the way I think about it is there's so many conspiracy theories out there today. It takes nothing to have a conspiracy theory, right? With social media the way it is. And what I tell emergency managers is one thing you better think about is social unrest. Because if space weather comes along because of the power general outage for people, they are going to count up on all sports and things of what that might be. You're not believing in the agency. You got to start educating them now, getting plans now, so that it's easier to communicate when it actually happens. They can trust you better. Now, you can stay informed yourself by subscribing to any subscription services on our webpage. You can subscribe to any product that we routinely issue, and you can get alerted by email of when one of these things goes out, to watch or warning or whatever this is in the podcast. This is a breakdown of our 40-ounce words that covers all three scales, where you find it on our webpage. It even gets the probability on the R scales of over stuffing. Doesn't do that for the geomag, but we're going to start doing that here soon as well. We're doing more communications. You see my face on the way because I started this effort. Nobody else is willing to do it yet. Get from the camera and get out there on social media and do an actual video live briefing, which is what I've been doing. I started that. This is where the one and only government shutdown of the many I've experienced has been held from the way. And that was that we were expecting the G4 greater event. This was for the November Veterans Day score materialized. And we were going to set up through our public affairs officer and weather service a mass media briefing. I couldn't use them. They were in shutdown. They were on third one. So I picked up my laptop, this one right here, put it up in my hand, turned on the camera, started walking around the forecast office, giving a talk about what's happening, what's going on, what it means. It was just an experiment. I had no microphone at the time. Put it out there. I thought, okay, let the cast me do it again. Are they going to be bitching about can't hear me? Are they going to be yapping about my shirt or what I look like? No. I was amazed. I could not believe what I saw from comments pouring in. They loved it. They finally got it. They understood it. They trusted it because I was live walking around the forecast office. I wasn't editing it. So now I'm in this pickle where I have to do this mostly unedited though. All right. But now I get to use the good phone, put the what do you call it? A gimbal, the vibration thing on it, scan around. They even have somebody filming me, trying to. So here's my goal. Now that we've established this, and people love it, is the next big G4 event we're expecting. I'm going to do the video update brewing. The time you put out the watch, and I'm going to let them know where we're at. Connect to your lives or in the case to you're going to get a progress report all the way through the event not in the end. And that is a major step forward because the public suddenly is aware of us. I mean, maybe they weren't even before, but now they are. So yeah, that's where we're going to go from beginning to end as we continue these here in the future. And with that, I think I've talked enough for you. And you can go get elsewhere. You get the training resources, board coming out there all the time. If you want to learn more about skateboard, it's definitely a good Boulder. So yeah, it's been a fun chatting with you. You got any more questions? You can have you today.
So were there any changes to personnel or budget in the last 16 months?
Budgets have changed just like they do at any point as things happen. For us, we're still trying to sort out. For the weather service, I think it's been favorable. For us at SWPC, it's been favorable. Just travel budgets have diminished a bit, so it makes it a little more difficult. Entails more virtual conference attendance if possible. Personnel, we're able to hire again. So we are able to hire. What's that?
Did those come through?
Yeah. We were impacted early on.
Yeah.
Yes, we were impacted. We did have to let some people go. We have since been able to hire some of those people back. Someone chose not to come back and receive new people. So, yes, we went through quite a dramatic change. But fortunately, we never let our ability to operate. We were always able to operate, just not as easily with less staff. But yeah, now we're able to get back up and get back where we can be. So we're in a good spot.
Are there any summaries or regular reports on power outages that are caused by space weather events?
No, there is not. So the small scale stuff, like the couple of thousand people in Washington, Idaho, unless I've seen something about a post about that or reported to me by a forecast office out that way, I never would have known about it because the NERC isn't required to report a major power outage. I think unless that's like 25,000 and more people. I could be getting another one, but it's a significant number of people. Then they're required to report it, and then you may find out, yeah, this may have been due to space.
Because Excel, for example, here, at least our experience in South Boulder, they have outages all the time. Sometimes they report them, many times they don't.
Yeah. I think it's the same for space weather. It just depends on the number of people or if they chose to or not, but they definitely are required to report positive energy at a certain level of impact to a number of people. I think that number is 25,000, but I'm not 100% sure about that. So yeah, when I find out about these things, it's usually from monitoring stories on the web and news, like to Australia. I found out about that because I happened to stumble on something in Australia. I mean, nobody's required to report the information about impacts to us, so we have to try to seek them, and it's difficult. It's also difficult because there's competing interests and legal repercussions, right? So insurance considerations, satellites may not want to tell you they experienced the problem because they don't want to lose faith with their customers or raise their insurance costs or whatever it is. The power grid, they're not going to hide information, but they're not going to share it unless they really need you, right? Because they got other things to worry about and deal with. Things like that, we run into that kind of problem. So we don't always hear about them. Even aviation, unless our normal sources give us information or find the time to think about it, we're not going to hear about it.
One other question. What's China? What's the Chinese experience with this? Are they deeply into it, or are they not deeply into it?
I don't know what their status is when it comes to space weather, what they're doing, but they are part of the consortium for the International Civil Aviation. It's the China-Russia consortium. They take, but we're actually turning over to them when we're done with our 2 weeks. Then we break that and they take over that responsibility. So they have a vested interest in space weather as well. And as I mentioned, doesn't matter if it's China-Russia because of the space weather, it's concerned all. We're able to freely communicate with them when needed on our way to do that for the International Civil Aviation. So that's going to continue to happen. We don't currently get any information from them, and I don't know if they're using our information or if they have their own resources out there. I really don't. We are trying to use private sources as well, like a lot of the satellites up there that are relying on us and they want so much more support. Well, another smart thing that's recently started being done is to use privatization sources. Instead of investing our own money into something, maybe get a so-and-so who you support and provide us information, like SpaceX, for instance, into one example of many. So that relationship's trying to be forced now as well, which is good. That's a leap forward for us. We can get so much more information if they freely share that to us and want to be a real core partner, just like they use ours. We don't charge them to that GOES imagery or that particle information. We could, but we don't. So we kind of want to turn it back.
This is fascinating. I'm really impressed by the fact that you can forecast to some extent these extreme storms and their impacts. Of course, any forecasting exercise is subject to type 1 or type 2 errors. And I know in Boulder, when Excel says, well, we're going to shut down the power to get the talking down trees that cause fires. And, some, people think about it, yes, and how Excel overreacted and made us move all sorts of food from our refrigerator. And of course, I'm realizing, well, sure, that was unfortunate, but we want to find the other guy there, where he failed to shut down and cause a huge fire. So what strategies actually like new when you present a forecast to the public?
Yeah, so for the power grid, they're getting pretty good information once I asked this to that early load predictions that I gave them. So I don't envision them taking a preventive precautionary response to measure where they shut off power because of the space weather storm. They're going to try and weather the storm, and I think they can do that with the mitigation measures, with the early word from us. And it's probably true, they probably can. But they would have to shut some things off if it came down to it. They don't want the transformer to get damaged to get operable. So if it becomes a threat, they'll just have to shut that one off and hopefully carry on over to the other one. So there is a risk to that. For the general public itself or other customers that use their information, it's tough to say. Satellites in space, the most extreme thing they can do to that would inhibit their operational ability would be going to what's called a single configuration, which basically means that it's not a duck and cover, but they kind of turn certain things off, the abilities off, so it's not fully functional until the storm passes. So they could do that, but odds are they won't do that for even a significant solar age storm. Why? Because it's still very unlikely that they're going to get that proton hit just right, in just the right time, and just the right spot to cause a massive anomaly to happen in electronic component to make that satellite uncontrollable, which has happened in the past. It's just so highly unlikely. So I doubt they'd risk the loss of revenue to take a stable configuration. But they could. There's an extreme measure that they could take. The public themselves, all I recommend to them is be more space weather ready, more savvy about what this all means. Don't get caught up in the internet apocalypse news story you might be seeing, or the massive fissure on the sun is going to cause whatever. Don't get nuts. Come to us. Get the real source of information. Understand what that stuff means. Follow the forecast, get out and concern. And to be ready, just like you need to be ready for Boulder, or anybody should be ready. The same thing as you do for terrestrial weather, like the possible power, if you do a winter storm, you might have a generator. You want to make sure you've got some canned food around. Think the same way. So if you're already doing it for terrestrial weather, I don't think you have to do anything else for the space weather. It would get a lot longer lasting, perhaps, which is something to think about, but I don't think it's anything you have to massively stock up on and be ready for.
Yeah, pretty much. And to what extent are your forecasts geographically tied, or if they're more we're forecasting a major event here, and we can't say it's happening right here 20 miles south of Detroit and not right. Is that
That's where we want to go for the electric power grid. Right now, everything's still planetary in nature, or so when we put out these things, it's a planetary estimate. We don't know for sure what area of the world might be more prone to this, what timing that might be. So you can get an idea for geomagnetic. We never know for sure how it's going to evolve. It has to build a curve. So we are not even close to that regional specificity yet, but we're getting there. We think we can get there for the power grid. To give them, it's just a matter of if they actually want that. We just found out at the Space Weather Workshop that he's had that at least one entity in the grid could care less. They want to know what the maximum thing that we're expecting. In other words, they're satisfied with what we provide already, which is the maximum we're expecting. Because that's what they plan for, and that's what they go with. Others do want that regional specificity. So we're going to learn a lot more about that. The test bed experiment in August, specifically dedicated to the power grid. If you didn't know, we've got a massive boom out of SWPC. Almost twice as big as this one, but not quite. That's going to be full. Power company folks, research scientists, us, other involved parties, Department of Energy person will be there, and others focused on what the power grid needs, and we want to get to regional products, like you talked about. So then, say the northeast part of the country knows that they should be more concerned and say maybe more concerned about over here in Texas or something. Right now, in that simple thing I showed you, it's a massive rectangle, right? It makes it look like an equal risk. We know that's not the case. But we also know that different regions of the country have different levels of what their equipment has to be ready for. And the further you go southward, that threshold goes down. So we can have something very impactful to Texas because they are not required to have their equipment running just based off 1 volt per car. Minnesota may have to be ready for 10 volt per kilometer. Texas may have to be ready for 1 volt per kilometer. So if we have a storm that you think can get over that in Texas, that's a problem for them. So that's why regional specificity is important as well. And we want to get there.
Is there any impact on maritime?
Yes. A lot of maritime areas still use HF and or GPS. And yes, matter of fact, a lot of maritime, I understand, still go to our simple version of the weather radio, which is a 3-hour message that we send out that gets broadcast out on some radio frequency somewhere. And I understand their islands can cling into that and do still. But we don't communicate directly with any maritime interests, but I do know that they use it.
And so there's new kind of autonomous vehicle navigation for maritime. So that's going to be impacted by this as well.
Potentially, depending on how it operates. Yeah, if it's GPS driven, I don't know ins and outs. So I do know that I did talk with not only FEMA out in New York, but a harbor was part of that. And I think they just want to understand more because as they get into the docks or whatever, there's a lot more relying on GPS or something. So they're trying to understand more about what gives susceptibility. I don't know, they need to add with any centimeter that, deep they need to be accurate.
And then there's some sort of correlation or connection with impacts and earthquakes or volcanoes.
I have heard that, and every time you put out a geometering storm watch, somebody will walk through and say, "Oh, there'll be an earthquake somewhere." I don't know if there's a real correlation. It's not something we're dismissing because we know that this is something that's being looked at as a possible connection. Whether there is or isn't, I have no idea. So we don't dismiss it. Like we do something when it comes to space flight is not going to affect your cell phone unless the power goes out, honestly. Not fully true, but for most part it is, right? So we don't dismiss that about, there's geologists that are even studying that kind of thing to see if there's that. And if there ever been one, well then there's another thing to think about. But for right now, as far as we don't see the connection, but it doesn't look good.
And we're going into a solar minimum now. So the probability of a Carrington event goes up.
Go down. If we go towards solar minimum, it's going to go down. You can still have an event happen at any time. I remember when I was in the Air Force still at the Solar Observatory out of Puerto Rico. It was like, look at this space loaded from cool silent Korea, on sunspots and according to where I look now. And it was 1996, I think. So we're right solar minimum. And I remember recording an event on the sun. It wasn't a flare, it was something called a film. This area of solar cloud was trapped by a magnetic field. And it disappeared. And when it disappears, one of two things happen. Either it ejected into space or something changed and gravity pulled that material back down and it got reabsorbed, as we call it. Well, a geomagnetic storm hit about a day and a half, 2 days later. I remember Swipsy here in forecasters thanking me for my recording I did on that film disappearing. And it turned out that particular storm, the geomagnetic storm is responsible for a satellite that went corrupt out there, or any other related. I don't know going out that stolen thing. That was during solar minimum. So yeah, even during solar minimum, things can happen. It's just that the most energy and the most activity is happening around solar maximum as we come down. Yeah, you can go for a number of months during solar minimum where we're really just reporting coronal hole. I didn't talk about those stages in G1, G2 type storms and nothing major going on.
Got a question. You talked about how, like, an ejection is, the flare is going to hit us just as bad, whether it's right on the horizon of the sun. And then he said, as long as, even if it's low on the horizon, it's going to hit us. But I wondered, for these different kinds of events, how much difference does it make, whether it's low on the horizon or whether it's right at noon?
A lot. You're right. I did not talk to that. So it's a good point to point out. So for solar flares, you got it. It doesn't matter. The effect of the Air's magnetic suspension. For solar energetic particle events, the radius, it does matter. So if let's say this is the sun. Rotates. This is the east side of the sun, by the way. Not the west, like it's on the mountain, east sand. Let's think about the sun rises in the east, so if they just rotate the view from the east and they rotate out of the west, the sun sets in the west. So if the solar flare happens over here, what happens is magnetic field lines are coming out from the sun as well as clustered around. And when they come out at about 2.5 or so solar radii, they curve. Why? Because of the rotation of the sun, so giving its curve. And these solar energetic particles, they're going to move those field lines. They spiral around them. So they come out from the sun over here, and then they curve away from Earth. So if you're Earth, now it comes to the center of the sun, same thing. It comes out, and it's going to curve away from Earth. You get over here, it comes out, and it curves right toward Earth. So as you get over into this western area of the sun, even to the limb, even beyond the limb, you're getting impacted by this storm. Matter of fact, you had a massive CME happen 2 days ago. but it was just beyond the line of the sun. So we saw this explosion out this way. We realized we weren't seeing anything on the earth facing side, so we knew it was that way. Well, guess what? We got hit with the solar radiation storm. It takes a lot of energy to cross those magnetic field lines. So if we did a solar radiation something over here, that's a very strong prolific event. We crossed field lines and got all the way over here and came over to reach Earth. We had a solar CME happen on the total opposite side of the sun when we got hit with a pretty decent decimal storm. That's scary. What would that storm look like when then directly headed to Earth? Could have been one of those sort of events. And then for geomagnetic storm, the closer it is to the center of the sun, the more likely we're going to be in the bullseye. They can be over here. That storm we had in January, the Martin Luther King Day storm, that was a storm that happened over here. So most of that energy missed Earth when we got hit with a decent chunk. You saw how strong that was. I can only imagine what that would been like if you had been hit from the vent death center.
Yeah, and how much does it matter with the Earth's, like, whether you see it in dawn or whether you see it in noon? Do they different events affect us differently depending on the angle that we happen to be guides at?
Yeah, it does. It came in around the equinoxes, so the spring and the fall. You just see a lot of news stories lately about, oh, it's fall, get ready for the aurora. Well, that's not really true, but there is some truth to that because during those seasons, we're kind of even on the solar equator plane, and that allows magnetic responses to be a little stronger than usual. You can connect a little easier into things that way. You cannot offset below the solar equator. There's a lot more science that goes on that's beyond my brain, but there's a definite paper and study that's been on that, and it's true. It is an actual effect. So whenever we're forecasting a geomagnetic storm for an event, and it happens to be June, you may get a normal attribution, but if it's March, give or take a month even, or September, give or take a month, you may escalate that number a little bit because we know that could have a more pronounced effect on the geomagnetic storm. As far as the other activity, other than daylight with their flares, time to day at seasons of them now. Okay, that's this.
With all this activity now about the moon, would solar weather affect the moon even more dramatically than the Earth, given that there's no atmosphere?
For solar radiation storms, yes. For solar flares, unknown because I don't know what equipment they'll have on there, but I'm glad you asked that question because, yes, if we end up putting a moon base on the moon, guess who's going to be providing a space weather forecast for that moon base? Yeah, we are. How weird is that? How cool is that at the same time? So, yeah, space weather will be a factor on that moon base, and anything they're doing outside, they might scrub, just like an EVA, they might scrub if we're expecting or seeing something arrive. They will probably get space weather sensors out there. Like you get your backyard weather station, there'll probably be something measuring radiation, probably measuring energetic particles, X-ray levels, whatever. So that'd be kind of cool. But yes, we will probably be because we're from Moon to Mars already. We go to the Mars, by the way. Guess we can be responsible for that space weather condition. We are.
So I'm just curious, you got an impressive website, but I'm noticing these 27-day forecasts.
Yes.
How would we talk about that?
Yeah, Ken. There's also, I don't know if it's still on there, but it's a 45-day or something.
Yeah, there's something about 40. You would say, yeah, 45 days.
Yes, that is satellite and space launch having huge interest in the long-range forecast, like you're pointing out there. And due to different reasons, I haven't talked about something called solar flux at a certain wavelength. But nevertheless, that's not the most reliable forecast we could have because it's so far out. You cannot take into effect like sunspot groups and sunspots beyond like 70 days to that. So we go out that far, it becomes much more less accurate. But if it's a feature like a coral hole, and you want to go out and chase the aurora, for instance, it's something to pay attention to because if it's a coronal hole, those can be very persistent features. The coronal hole, I didn't talk about it, but it's less dense area of the sun, so it appears dark in some of the imagery. And it's where magnetic field lines go all the way out in space beyond Earth for you can that. And that allows the solar wind to escape much faster. So those can cause geomagnetic storms, even up to a low end G4. Very, very rare you see it that strong, but we have seen G3 a number of times with the coronal holes. Usually it's in the G1 to G2 range. For Colorado, CD Aurora, you kind of got to get into the high, I won't say high end anymore, people capture it with their phones, but G3, you might see it here in northern Colorado. So if you look at that forecast and you see that AP number that's on there, the AP number is another index. You get the AP, you have the T-scale. Get familiar with the AP a little bit, and you start to see a higher end number on there. It's probably referring to the current coronal hole that we're expecting to rotate back into position, and that can cause a geomagnetic storm potentially or a Aurora chances. So the Aurora viewing community is very well aware of it. The satellite community is very well aware of that. Watch numbers forecast in there. But yeah, it's not a huge investment in our time. It's really our version of climatology. We call it recurrence. What happened before is going to happen again. The coronal holes, it's very true. It could. For anything else, it's very untrue.
Well, thank you very much.
Hey, you want it?
This came on.
Hey, you bet. My pleasure. It's a fun career field. Could be very, you got to be willing to take your kicks. You know, we've been hit by storms and we were thought to go in the other direction from the sun. We've been missed things that we just don't see. Sometimes
Free audio post-production by alphonic.com.